In this video, we're going to look at problems that deal with rates and proportions. So proportion problems look something like this number 1 right here, where you have a fraction equals a fraction, which we've looked at already a little bit in our course. So what we're going to do is warm up with a few problems, kind of getting used to that cross multiplication again, since that'll come up. And then what we'll do is also talk about what happens to units when we're doing this. So this first problem, when you just have a fraction equals a fraction, this is where we can bring in that cross multiplication, where you can multiply across the equal sign, numerator to denominator, denominator to numerator. So what we would do is just drop down the equal sign, so keep that as the separation. And on one side we have this 17 times x, and then the other side we'd have this 3 times 85. And then we can go about solving for x. So on the left-hand side, it's a 17x. On the right-hand side, 255. And then just divide both sides by 17. And we get x equals 15. So when we have this fraction equals a fraction, or fractions, that's what's being presented as a proportion here. It's the same idea. We can use cross multiplication to solve. So let's see what happens when we change this proportion problem to something with units. So same cross multiplication. And let's see, on the left-hand side, let's take this q times 11 miles. And I'm just going to have the units kind of stay connected. There are much quicker ways of doing this than what I'm going to show, but I'm going to show kind of the long way so you can really see how everything separates out. So q times 11 miles, and then on the right-hand side, we'll have 5.5 miles times 10.2 minutes. So I'm going to leave it written out long there for right now, but the idea is if I was solving for q, I want to get q all alone on one side of the equation. But right now it's being multiplied by 11 miles. So what I would do is I'd want to divide by that 11, and I'm going to keep the units attached to it. So I'm going to divide by 11 miles, divide by 11 miles. Then on this left-hand side, it's like 11 miles and 11 miles would cancel out. So I just have Q. And then with problems like this where you have units and numbers working together, you can separate them out in that in terms of numerically, we're going to throw into the calculator 5.5 times 10.2 divided by 11. So you can put that in the calculator and just get a number out, which should be a 5.1. So you can kind of separate the numerical part. And then if we think about our units, now with units here, if we just focus on that we have miles times something in minutes divided by miles, just like how variables can cancel out and even numbers, if you have the matching units in the numerator versus denominator, those units will just cancel out with each other. So if you have something in miles and dividing by something also in miles, they just cancel, and so that leaves us with our only units of minutes. So this is a tool that we're going to use, especially with unit conversion, where this is a way we can convert units and things will cancel out, so then we're left with a different form of units. So let's talk about setting up things in terms of a rate. So your car can drive 338 miles on a tank of 26 gallons, and we want to express this relationship as a rate. So a rate is usually something per something else. So with this, it's that we'd have these number of miles per, and then we put in terms of the gallons. So you might have heard this if you own a car, miles per gallon is typically how they talk about the mileage of your car. And it gives you an idea of how far you can get on just a single tank of gas. And with this notation, and maybe you've seen it shortened with MPG, miles per gallon, but the wording here, when you see per, you could think of that as division. That's going to separate. And then the wording here, like it's saying miles per gallon is different than gallon per miles. Order matters in that what comes first is specifically the numerator. So miles is going to make our numerator, and then denominator is going to be the second form of units. So With this, it can set up how we make our rate. So what we're going to do is put miles in the numerator. So we have 338 miles, and then per, which will be the division, and then the denominator will put gallons, which was 26 gallons. And then what we can do is simplify numerically. So 338 divided by 26 is 13. And then our units, you can write this a few different ways. If you keep it as a fraction, you could show miles over gallons, or you can switch it up to the phrasing that we wrote on the left-hand side there, 13 miles per gallon. So with that, we get an idea of our cross multiplication and cross multiplication with rates. Now, something that happens here when we set up a rate like we did in number 3 here is that we can then start comparing it to another scenario. Like this 338 miles and this 26 gallons, those working together is specific to our car. But then what we could do is talk about, like, say we drive 500 miles. Then what can we expect for gallons? So what we can do is throw in an unknown. So we're going to have a variable coming through in these questions of something unknown. But with this setup of a specific scenario of knowing both the numerator and the denominator, that gives us one side of our equation, and that helps us solve for our variable. So let's look at a few examples, and then you'll have a few to try out for yourself. So with this example, we have Cody and Clyde hike 5 miles in the Mount Rainier National Park. The hike took them 3.5 hours. They're planning a similar hike this weekend, but the distance is 6.2 miles. So this is what I was saying up above there, is that they're giving you information in terms of something that works together. That 5 miles and that 3.5 hours, those go together with that one hike that they did. So let's go and even write that down, that last weekend when they did that hike, we know it was 5 miles long, and with that goes the 3.5 hours. Now we're planning this similar hike. So this next hike that we're doing is going to be similar. So we're going to assume it's kind of similar difficulty, but we're changing as a distance of 6.2 miles. So we'll have 6.2 miles, but then our unknown is how long is it going to take. So that's where we're going to throw in a variable, which you can use any letter you like. I'm going to go ahead and use X. So we should be solving for something in time. So what we can do is set up this proportion problem of a fraction equals a fraction, because then we can use our cross multiplication to solve. And then on one side of the equation, and this, again, you'll hear me say this so many times in the videos, but this is another one of those scenarios of many paths to the answer, and whatever you've learned before, absolutely use it. I'm just going to show the way that I explain it. But what I typically do is for one side of the equation, I put those two pieces that are working together. So that hike from last weekend that they did, and those two pieces, I'm going to make that a fraction. Now, order doesn't matter here. It doesn't matter what goes on the numerator, what goes on the denominator. And I'll show you how it does matter when we make our second fraction, but when we make our first one, you can set up the order of things. So I'm going to set it up 5 miles to 3.5 hours. Then when I set up this right-hand side, I have the 6.2 miles, and this is where it does matter. By setting up this first fraction, I'm saying miles in the numerator, hours in the denominator, and it has to stay the same on the right-hand side as well. So with that 6.2 miles, I can't put it in the denominator. It has to go in the numerator to match the form that I used on the left-hand side. And then X, which is representing time, will go in the denominator. And now it becomes a cross multiplication problem with units involved. So I'm going to cross multiply. So on the left-hand side, let's say I have that X times 5 miles equals, and on the right-hand side, I'm going to have 3.5 hours times 6.2 miles. And then what I'm going to do is divide both sides by 5 miles. So that on the left-hand side here, those 5 miles cancel out with each other, so I just have X. And then on the right-hand side, in terms of what you'll plug into a calculator, you'll have 3.5 times 6.2 over 5. And then for units, those miles will cancel out, so we'll just be left with something in terms of hours, which is exactly what we wanted to have. So the units will always work out with these to cancel out in a way that you get the units that you're looking for. So numerically, that should be 4.34, and then units of hours. Let's look at another example together. So here we're going to have a recipe, and for this first way that we're going to do it, we have 4.5 cups of rice matching up with 4 people. So those are two things that are going together in this problem. And then what we're doing is we then want to solve for cups of rice. So that's our unknown in this case when we have 14 people. So what's going to happen is I'm not going to know the number of cups of rice, but I know I have 14 people. So to set up my proportion problem, I want to work with a fraction equals a fraction. And on this left-hand side, I'm going to set it up in terms of what I know. So 4.5 cups to 14 people. And then for my second fraction, in terms of the numerator should be cups of rice, and that's our unknown. Denominator should line up with the number of people. And sorry about that, that should be a 4, 14 people. And then it becomes our cross multiplication problem. So let's see, we'll have 4.5 cups times 14 people equals x times 4 people. But we want to get x all alone on one side of the equation, so we're going to divide by 4 people, divide by 4 people. So when we're solving for x here, on the right-hand side, that'll all cancel out, so we just have x. Numerically, you'll find 4.5 times 14 divided by 4, and then our units, those units of people will cancel out, and we're left with the units that we want, which is cups. And numerically, that should come out to a 15.75 cups of rice. So here's some problems for you to try. So if you want to try some of these for yourself, you can pause the video, and then I'm going to go through the solutions. So if we have an administrative assistant, types 250 words in 4 minutes, so there's our pieces of information that go together, 250 words, matching up with 4 minutes. And then we want to see our next scenario. At this rate, how long will it take? So we don't know the time that it'll take, but what we do know is how many words we're typing. So that'll be 3,000 words. But then the number of minutes is unknown. So we're going to set up fraction equals a fraction. I'll do 250 words per 4 minutes. And then on the right-hand side, words in the numerator and time in the denominator. Cross multiply, so we'll have x times 250 words equals 4 minutes times 3,000 words. And then we're going to divide both sides by 250 words. So on the left-hand side, 250 words will cancel out with each other, so we just have x. Numerically, we'll have 4 times 3,000 in the numerator, divided by 250. And then for units, words will cancel out, so we're left with something in minutes. And when we simplify, it should be 48 minutes. All right, this problem here is kind of a challenge problem, but it ties us all together and also brings in some of our geometry questions. So we have these two scenarios. We have the jumbo pizza versus 2 medium pizzas. what we want to do is compare which is a better price, which is a better deal. And with that, what we want to get is this: how much are we paying per square inch in terms of dollars per square inch. Now, problems like this, and you'll have a similar problem on your homework with My Open Math, even though they're giving you diameter, comparing diameter to cost doesn't quite work. It's because it isn't really about the length of the pizza, it's more about area of the pizza. So you wouldn't want to start using this diameter per dollar amount and then compare to diameter and dollar amount. We have to use area. So that's going to come up in your homework. Just be sure that we work with area. So what we want to do is with the jumbo pizza is actually figure out how many square inches are in the jumbo pizza, so we can get an idea of dollar amount to square inches. So as a reminder, area with circles is pi r squared, and they're giving us the diameter. So with the jumbo pizza, we have 16-inch diameter. So if we need the radius, we just need to cut that in half. So we have a radius of 8 inches. So for area, we're going to have pi times 8 squared. And when we put that in our calculator, that should give us a 201.0619 square inches. And we'll just go to 4 decimal places for accuracy here, just so we don't allow too much error in. So there's area for the jumbo pizza. For 2 medium pizzas, so a medium pizza is 10 inches in diameter, so the radius is 5. So for the area of one of the medium pizzas, we would take pi times 5 squared. So that would be one of the medium pizzas, but we have 2 of them. So what we're going to do is multiply this by 2 to double the area. So when we do this, we should get an area of 157.0769 inches squared. So in terms of comparing area, if we were just interested in eating more pizza without thinking about the cost, jumbo pizza. That has a much larger area, but what we want to understand is, what about bringing the cost into the equation? How is that affecting things? So what we're going to do is look at the rate of price per square inch. So for jumbo pizza, we're going to make a fraction where in the numerator, that'll be our dollar amount, which in this case is $19.50. And then I'll go ahead and keep the units attached there, and then divided by the area of 201.0619 square inches. So if we simplify that down, it should be about 10 cents per square inch. If we do the same thing for the 2 medium pizzas, take the dollar amount, so $20, divided by area, and simplify that down, and we'll see that is 13 cents per square inch. So in terms of cost, jumbo pizza's coming in around 10 cents per square inch, while the 2 medium pizzas coming in at $13 or 13 cents per square inch. So with that, the 2 medium pizza is more expensive. You're paying more for a square inch of pizza with the 2 medium pizzas than with the jumbo. So if you're just looking for the better deal, then that'll be the jumbo pizza. So that's where it can't just be a comparison of area. You want to bring the dollar amount in to see where's the money better.